Welcome to this follow-up video that talks about a monorepo that contains Angular, NX, firebase authentication, and faster database. For this video, we will talk about an architectural pattern that helps to write code that scales. So I call it the PARQ pattern. PA stands for parser, R for resources, and Q for queries. The goal of this pattern is to write effects that are easier to read, but also to decouple the models used in the application from the objects coming from the outside world, namely the database. So now in application, we do have queries and we have user queries, and the user queries is related to the user document. So in a like manner, we also try to write to create a folder called parsers, and within that folder, we also create a user parser, and that parser related to the user document. So let's do that. So our parser will contain two main functions. So one is called to use entity, and then it will take as parameter a user, and then it will return what I call a user entity. So we don't have yet the model definition for a user. I guess we had created one before, but it is not spotted. So we can move this user here. We can move it to a model called user. Actually, let's just do that. Actually, yes, it should be much way better to do that. So let's move it to a new file. I rename it. Then I call it models user. So we have our user, and our user contain coins, a list of coin, and our model, which is the model coming directly from our database. Our model doesn't depend on the coin that we created in our store. So these are two things separated. So let's create here as well uh, coin interface. Because what we are trying to do here is to model the definition of the document user that we do have in Firestore. And uh, a coin has an ID, which is a string. So what we created here is that we created the definition of our user document. So now what I want to do is as well is to create an interface that I call a user entity. It also contains a list of coins, but here coins are always an array of coin entity. So let's create also the coin entity. So these models, they look almost identical to this one, but they are not the same. So these models are coming from our database. These models are exterior to application, and within application, we'll be using uh, this object here. So it's true that they look alike because we have a very simple application. But as the application is growing, we will quickly notice that these objects are not the same. And we want to make clear right from the beginning that what is the object coming uh, from the outside of our application, and what is the object that belongs to application. So now if we go to our parser, so let's import these. So we return a coins, which is data.coins. And when these coins is empty, uh, we use the empty array. So our coins will always be an array. So by making this little conversion here, so we make sure that within our application, coins is always defined. And also there is a second function that our parser will need to contain. Then I call it to user, and it will take as a parameter a user entity, and then it will return a user. So I can do something like if data.coin uh, is not empty, then I want to add uh, data.coins to my, I want to return data.coins. So if data.coins if data.coins if the length of data.coins is empty, then we return uh, an empty object. If not, we return an object that contains coins with the list of our coins. So that way we fulfill the contract of user. So again, with our simple application, these two parsers here, they look alike, but in a real application, you will quickly notice that uh, these these parsers are lifesavers. They make application more robust, as it allows to identify what is the object of our applications, what are the objects coming from the outside world. And it's good to make these two objects separated. Uh, and then it allows the developer to be able to modify objects that are used in the application, knowing that those objects will not impact the objects of the outside world, namely when you are making queries to a database. So we've written the first element of our PARQ pattern, which is the parsers. So now let's write the second element of our PARQ pattern, which is the resources. So we go to our store, and within our store, we write a coin.resources. Coin.resources. So this is an injectable. So we don't provide it in the root. So you will see later why. So our coin resources, so we'll inject our user queries. And our goal is to make our effect, as I said earlier, to make our effect uh, easier to read. So our load coins, instead of having the intelligence of directly here within our coins, so we'll try to perform this operation within our resources. So our resources will contain all the intelligence, and then our effect here will just call the method to perform the operations that we need. So I will copy this. So let's create a method called getCoins. Return this. I will need to inject as well the auth. Now, something very important as well here is to use our parser that we created. So here we have our user, and we want to map our user against its equivalent user entity. And now return the coins, which are of type coin entity. And now in our effect, so let's import these coin resources first. So tell me, what do you think? It's not simpler to write our effect this way. So our effect is just calling the current resources, and our current resources is getting get coins. So does it not look way simpler? I'll be very interested to see what you think about this approach. And so as I said, our effect becomes lightweight. So our effect contains first a filter on the actions, then a switch map to perform the operation we need. So this one, and then after, it just return an action on success. So here is a coins. So we don't need to perform here any operation. We just return in the coins, and then if there is an error, we just return a coins failure. So Personally, I feel like writing effect this way makes the effect uh, easily readable, and it makes uh, the application easily scalable as well, as these coin resources provide an extra documentation for anyone getting into developing this application for the first time. So, which is something not to be not something that we need to always uh, need to aim for. We need to aim for the readability of the code that you write. It's true that adding a resource, adding an effect, it makes it's a little bit verbose, but for me, the fact that it makes the application easily readable, the fact that it is easily scalable, it it's worth it. It's worth to add these additional layers as you are writing your effects. But I'll be interested to know what you think in the comments. Um, so we can do the same thing for the other effect that we wrote. So let's do that. So here I rewrote our application to leverage our resources to set coin and to load coins, and our effect is now way simpler. Um, so as I said, what is the structure of our effect? So our effect contains a filter of actions, then it just called the resources to perform an operation, and then after it just return an action. It just returns an action. If there is a success, or it returns again a failure action if there is a failure. So with this PARQ pattern, I think that it makes application with NGRX way simpler and way scalable. So tell me what you think about this pattern. The end goal of this pattern is also to make sure that the object coming from the outside of our application are clearly separated from the object that are within our application as we use uh, the, the different method within our parser, the to user entity and to user. Now, it's true that within what I've done so far, we haven't used to user. We only use the to user entity to transform object from the user within our file store to user to the user within our application. So what we can try to do now to see how we can use both of our parsers, we can try to add, maybe let's add maybe to our coins. So here, let's use a creation date. So if the object is coming from the database, so the creation date will be a timestamp. And if the object lays within application, the ID will be a date. Sorry, the creation date will be a date. So, so it's complaining, obviously. So our creation date, we do not have it in all the scenarios since we already created coins without a timestamp. So let's suppose that we do not have our creation date in all the scenarios. So our timestamp could be undefined. But within our application, we do not want to use deal with undefined values. So here it should be a null instead. So we can see that the complexity of applications start to increase. So here we are dealing with undefined, here we are using null values. So clearly we can see the complexity of application is increasing, and we only have a very simple application to deal with. So that's why it's very important to differentiate what is the object coming from the outside of application and what is the object living within application. So we go again to our parser. So this could be undefined. And if it is, we use null instead. So it's still complaining. So the ID is missing. Actually, I could have done it in a better way by creating also a to coin entity. But so far so good. It's very simple for what we are trying to do here. So no big deal here. So if our coins has a length, so we return coins. But here, the coin living within the application has a date, but the coin that we need to send to the server, the user, it needs a timestamp. So we need to do the same formatting or the reverse formatting here. So we use a map. And as for the creation date, since it can be optional, depending on if uh, you have a coin the creation date or not. So you do not want to save the null value, for instance. So we just created to user um, to user we are converting to the user from the user entity, and we are making the we are converting the data. One has a timestamp, the other one is using a date. But here, it's not that complicated because we are trying to make sure that what is if we are living within an application, we are using the user entity, and if you are going outside of our application, we are using the user. So since you are making the separation between the two objects very easily, uh, it makes dealing with those data easier. Now, if we go to our component, a coin list component. Now, when we add a coin, we also want to add a date to it. We want to add a creation date. We are not using the interface anymore. We are rather using the coin entity that we created. So here we can safely replace all the coin here by coin entity. I think I made a mistake. Let me okay, let me replace this element one by one. Better of doing. So now we are adding a creation date to our coin. And if we now go to our queries here, so our queries, nothing is changed. Where we are really interested is to see what is happening within our resource. Uh, so here in our resource, we are taking a coin entity, and um, we can observe directly a coin entity. So this one is wrong. Here we are having a coin entity. Here we need to have a coin coming from the models that we created. But here we have a coin entity. So we need to um, we need to transform these coin entity to coin. So what we can do here is that one way to do that is we can go back to our parser that I was saying it previously. So this we can transform it to a method instead, to a function instead. So we do have some errors. Uh, and the errors we are having is that uh, it did not provide a coin resource. And it's true. I said earlier that we are not gonna define uh, a coin resource using provide in root here, because we do not want to provide it globally. We want to provide it only where our effect is loaded. So we now have to go to a route of our application and provide a coin resource here. So now application is loaded, and now let's suppose that I add a new coin. Let's go for BTC. So we add a coin. Now let's go to um, So here you can see that I have a creation date. But somehow uh, it is created twice. So let's try to debug this one. So I reload my application. I use the Redux. Let me add, for instance, LTC. Right. So LTC is created twice. We have BTC, LTC. Uh, okay, that's interesting. So let's see, let's try to understand why that's the case. One, okay, the reason why this is happening is that when we add a coin, uh, the coin is being added before we are making the request. So we are not adding the coin on the success. The coin is being added before we are making the request. That's why we are having this issue. So maybe what we can just try to do here is to change our effect uh, just this way. So we don't need this one anymore. We can just stick to this. And if that's been the case on altcoin success, can use the empty prop. So now application loads, and now let's add, for instance, Shaba Inu. So I don't have Shaba yet. If I add Shaba, how many Shaba I have? So only one. So we've solved the bug that we just noticed in our application, and now we can see that application is working as great as what we had last time. But now with the only change that we now are now leveraging the PARQ pattern by using the resources and by using parsers. And again, as I said at the beginning, now our effect is easier to read and application will be easily scalable. So that's all I got for you for today. So stay tuned for next video as we continue to add more features to this application.